Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad algebra problem, and we have n cubed plus 1 equals to n minus 5 whole square, and we've solved this problem for the values of n. So here we solve this problem by two methods. So here we discuss the method number 1. So in the first method, here we add minus 9 on both of the sides of this equation, and we get n cubed plus 1 minus 9 equals to n minus 5 whole square minus 9. Here we just add minus 9 on both of the sides of this equation. And now in the next step, here you see that we have 1 minus 9 will be equals to minus 8, and in the right hand side we have n minus 5 whole square, and we write this 9 as 3 square. And in the left hand side we write this 8 as 2 cubed, and we use the two formulas on both of the sides. So in the left hand side we use the cubic formula, and in the right hand side we use the square identity. So here we use the a cubed minus b cubed formula, and it will becomes a minus b times of a square plus ab and plus b square, and it is equals to, here we use the square identity, so it will becomes n minus 5 plus 3 into n minus 5 minus 3. So in the left hand side we have n minus 2 times of n square plus 2n plus 4, and we move all the terms in the right hand side to left hand side, but here we first simplify the terms, and we have n minus 2, and here you get n minus 8. So we move these two terms in the left hand side, and we obtain n minus 2 times of n square plus 2n plus 4 minus n minus 2 times of n minus 8 equals to 0. So here you see that n minus 2 be the common factor, so we take common n minus 2 from both of the terms, and we get n square plus 2n plus 4, and here we multiply this minus sign on both of the terms, and we get minus n plus 8 equals to 0. And now in the next step we simplify the terms, and we have n square plus n plus 12 equals to 0. So that here we have two cases. The first case is we write n minus 2 equals to 0, and the second case is we write n square plus n plus 12 equals to 0. So in the first case we get the value of n is 2, and now we move towards in second case, and in this case we use the quadratic formula in order to solve this problem. So that first we write the coefficients of this equation, and these are a equals to 1, b equals to 1, and c equals to 12. And our quadratic formula will be looks like in this form: minus b plus minus square root of b square minus 4 times of ac divided by 2a. So that we put the values of a, b and c here, and we obtain minus 1 plus minus square root of 1 minus 12 fours are 48 divided by 2. So after simplification we get the value of n will be minus 1 plus minus square root of minus 47 divided by 2, and we get the other two answers will be in this form: minus 47 square root over 2. So these are the other two complex roots of the given equation, and this is our first method. And now we move towards the method 2. So here we solve this problem by using the second method. So in second method, here first we rewrite the question statement as n cubed plus 1 equals to n minus 5 whole square. So this is the our question statement, and now we first open the square on the right hand side, and we write it as n cubed plus 1 equals to n square plus 25 minus 10n. So here we just open the square identity in the right hand side. And in the next step, we move all the terms from right hand side to the left hand side, and it will be equals to n cubed plus 1 minus n square minus 25 plus 10n equals to 0. So here we rearrange the terms and we write it as n cubed minus n square and plus 10n, and 1 minus 25 equals to minus 24, and this whole equals to 2. So that in the next step we make the factors of this cubic equation, and first we write this n cube and we write this minus n square as minus 2n square plus n square, and we write this plus 10n as minus 2n plus 12n, and we have this minus 24 equals to 0. So we easily make the factors of this cubic equation, so that in the next step we first take common n square from the first two terms and we get n minus 2, and here we take common n and we get n minus 2, and here you take common 12 and we get n minus 2 equals to 0. So here you see that n minus 2 be the common factor on each term. So here we take it common n minus 2 and we get, here you get n square plus here we get n and plus 12 equals to 0. So now here we have again two cases. The first case is we write n minus 2 equals to 0, and the second case is we write n square plus n plus 12 equals to 0. So in the first case you get the value of n equals to 2, and now we move towards the second case. So in second case here we need to use the quadratic formula. So first we write the coefficients of this equation, and we have a equals to 1, b equals to 1, c equals to 12. And our quadratic formula looks like in this form: minus b plus minus square root of b square minus 4 times of ac divided by 2a. So here we put the values of a, b and c, and we have minus 1 plus minus 1 minus 48 divided by 2. So here we just directly take some steps, because you put the values of this and here you have simple addition and multiplications. So now we have minus 1 plus minus square root of minus 47 divided by 2, and here you see that the negative sign occurs inside the square root, so it will becomes iota and it divided by 2. So this is the our other two complex roots of the given question, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.